welcome to my brand new series. This is in keeping with our OCR A-level chemistry series. But this time we're doing all the maths that you need to be able to perform in your A-level chemistry exams. So I'm calling this series OCR ChemCalc. So let's start. And this is the first video on this new series, ChemCalc, which is talking about relative masses. So we can see here we have it. So let me just briefly explain what this series will pertain to. So this series is all about the maths that you have to be able to do in your A-level chemistry exams. So if you remember, you will have 3 exams at the end of year 2, at the end of year 13 for your A-levels. You have paper 1, which is all about the physical elements and physical chemistry. You have paper 2, which is mainly about organic chemistry. And you have paper 3, which is unified chemistry. And in all of those 3 papers, at least one question will ask you to do some sort of calculations. So that's what this series is designed to help you with all of those maths things, because there might be some people that are watching this video who aren't doing A-level maths, so they might find this a bit tricky. So that's why I'm creating this series for those who are a little bit unsure of the maths behind that you have to do in chemistry. So this is the first video, which is talking about relative masses. So each video will start with will have a sample example question, which I will go through. And then if there's more than one question, then I'll leave the second question or the questions that follow for you to do. And then I'll go through it later on. But for this, since it's the first video, I might as well just give you a feel of what this series will contain by just putting one question. Okay, so if we think back to our first video on relative atomic masses and relative isotopic masses, let's define relative atomic mass before we look at this question. So, relative atomic mass, or AR as it's called, is defined as weighted mean mass of an atom of an element compared with 1/12 of the mass of carbon-12. So the relative atomic mass we denote as AR is the weighted mean mass of an element compared with 1/12 of the mass of carbon-12. So let's go through this question. First thing, and let's highlight the keywords. So a sample of carbon was analyzed by mass spectrometry and was found to contain 24% of carbon-12, 32% of C13, and the rest, this is important, the rest of carbon-14. Calculate the relative atomic mass of this sample of carbon. Okay, so they also have a worked example in page 36 of the textbook, but I thought I might make up my own. So let's go through it. So we have the first thing that you need to do is that you need to multiply each of these So the percentage here by the mass number of that isotope. So what I'm saying is, so for example here you would do 24.4 times 12, and then here you do 32 times 13, and then whatever's left times 14. So actually, first thing we need to do is work out how much of carbon 14 we have. So remember, these are in percentage. So you would do 100%, so 100 minus 24.4, let's do 0.0 minus 24.4, and that, if you do that on your calculator, 100.0 minus 24.4, that gives you an answer of 75.6, and then you do 75.6 minus the 32.0, and I can do this one in my head. That will give you 43.6% left over for carbon 14. So we have 43.6% of carbon 14. So now you would times 43.6% of this. So what you do here is 24.4 times 12, 32 times 13, and 43.6 times 14. And then you would add them all up together, 32.0 times 13 plus here 43.6 times 40. And then since these are in percentages, you would divide all of those by 100. So the AR would equal 24.4 times 12 plus 32.0 times 30 plus 43.6 times 40 all over 100. That would give you, you can type this all into a calculator, into a scientific calculator. So a scientific calculator is really useful, and I'll splash one up on screen now. So these types of calculators are really useful for doing calculations like this. So it is recommended that you get one of these calculators. But if we do that calculation, 24.4 times 12 plus 32.0 times 13 plus 43.6 times 40 and or divide all of that by 100, we get a little bit of a random number, and that random number is our answer. So our AR, or relative atomic mass, of this sample of carbon is 13.192. If it's more than 3, it's better to give the full number, unless it's more than 3 decimal places, which is 13.19 correct to 2 decimal places. So that is the final answer. So that's how you do calculate relative atomic masses. Thank you all very much for watching. Hope this was a little bit more useful. I will be doing more ChemCalc in the future as I build up the main series of chemistry. So I will be doing more ChemCalc videos as my series of my A-level chemistry series continues to grow. But that is it for this video here. Thank you very much for watching, and I'll see you in the next one. Goodbye.